that you can drive a whole ZigBee network system. So let's come to our project. And we are from Beijing Jiaotong University, and our project is the intelligent navigation and tracking system based on ZigBee. And I am Zhang Lingkang, who is the captain of this team. And our professor is Lu Yong, and these are my two partners, Yanman Zhang and Pengshu Chen. So today's presentation will be divided into two parts as a whole. The first part, I will introduce you about the ZigBee network system, which serves as a cornerstone technology in this whole project. And in the second part, I will introduce you about this whole project. So let's come to the first part, and there are three sections: a general introduction, and the location technology, and the Z-stack operation system. For general speaking, the ZigBee is a low-cost, low-power wireless mesh network standard based on IEEE standard 802.15.4. And there was a very important feature. ZigBee nodes can sleep most of the time, which is why it will save a lot of energy. And I will introduce why later. And on the right side is the protocol picture, and on the left side is the circuit picture, and based on which we build up our own hardware, ZigBee nodes. And for the location technology, there are two kinds of nodes. The one is the reference nodes, and another is blind nodes. And there is a very important concept: the received signal space indicator value. So let's come to look at this picture. The green node is the blind node, and the gray nodes are the reference nodes. The green nodes will talk to all of the reference nodes and receive the RSSI value from all of them, and so that it will know where itself is. And for the Z-stack operation system, it is like most of the operation system. There is one part of the core code which will repeat one and one again to detect the command. And the most important feature is this function, the power conserve function. And I will talk about this. For all of the general operation system, one of the code will repeat one and one again to detect the command to come, and then to execute the command. But in our system, if this green arrow is the current time, and all the red arrows are the time where the command should be executed. And for the common operation system, this part of codes will repeat again and again in this period of time. Actually, that do nothing, and the power is wasted. But in our system, it can sleep in this period and do the command at this point. And again, most of the time, actually the nodes are sleeping. But when the command is come, it will execute it, and that's the very important feature why the power is largely reduced. So the important thing is that the performance is improved in our project, and this is a very actually interesting application in this whole project. And then let's come to the second part of this presentation. The whole project has three functions as a whole: the navigation, tracking, and the controlling. Navigation means that the robot can lead you to the place you want to go. You just choose the destination, and it will calculate out the shortest path automatically. And the tracking, it will follow you behind you as you walk. And the control is that we build up a Bluetooth remote control system on our cell phone. And these are the other features of this project. And this can be applied to restaurants, supermarket, and factories. And actually, we have two versions of robot as a whole, and we bring the second version, 2.0 version, to Taipei this time. And then I will introduce you about it in 6 sections: the general introduction and the platform, and then the 4 functions, and in hardware and algorithm aspect. As a whole, it has 2 CPUs. Different CPU has different functions. And this is the whole circuit. And it has an LCD screen on the robot, so that you can control it using the button on the robot. And this is the platform of the robot. And for the most important, navigation, we use the 6 ZigBee nodes as a whole. 4 of them are the reference nodes, like this. It will be put into the 4 corners of the whole area it will move. And another 2 are the blind nodes, one connected to the computer, and so that the position of the robot can be revealed on the screen. And another blind node is on the robot, so that it itself can know where itself is, so that it can calculate out the path and to navigate for you. And this is the process we build up the whole ZigBee system to modify the Z-stack code and adding the location problem and using the serial port program to connect it to the MCU microcontrol unit on the robot and connect it to the computer on the other hand. And for the algorithm of navigation, it is a kind of shortest path algorithm, and this is a simple picture of it. And it is based on the Dijkstra algorithm to calculate out the shortest path, so the energy can be reduced in this aspect too. And this is tracking. We use two ultrasonic sensors to build up a tracking system. The 2 sensors are on the robot, so you just walk in front of it, and the robot is behind you, so that it can detect you using these 2 sensors, and it will follow you according to our algorithm. And for the fifth, we build a Bluetooth control using our cell phone. It is an Android application. It can use on your cell phone, and you can use it to control the robot at the same time. It is developed on the Eclipse platform using Java, and it is Android Bluetooth based. And the steps are pair the Bluetooth devices and send different codes, and then we can control it. And this is the third function of the whole project. And then last but not least, it can avoid obstacles by itself. It is really user friendly, because when it encounters with the obstacles, it can avoid by itself using these sensors. And this is a really simple algorithm of that. And as a whole, our system using the cornerstone technology ZigBee and to build a whole navigation and tracking system. And this is the whole picture of that. And thank you. And then let's come to the question and answer.